Welcome to my tutorial class on composite bars. In today's class, I'll explain another example on composite bars. Two copper rods and one steel rod together support a load of 400 kN as shown in figure. Find the stresses in the rods. Take ES is equal to 200 GPa and EC is equal to 100 GPa. So in this example we have two copper rods of equal areas cross section along with another steel rod is supporting a load of 400 kN. Now copper rods each having an area of cross section 1200 mm square, whereas steel rod has an area of cross section 1000 mm square. Assuming that load remains horizontal, all the bars will get compressed equally. So the deformation in all these bars are going to be equal. Now let us tabulate the data given. AS is equal to 1000 mm square. Area of cross section of steel is 1000 mm square. Now area of cross section of copper is 1200 into 2. Since there are two steel rods, we have to multiply by 2. So that will give the total area of cross section of copper. So two copper rods put together and the total area is 2400 mm square. The load P is 400 kN. So that is this weight which is acting downward is 400 kN. It's equal to 400 into 10 raised to 3 Newton. Young's modulus of steel is given 200 GPa, that is 200 into 10 raised to 3 Newton per mm square. Young's modulus of copper is 100 GPa, that is 100 into 10 raised to 3 Newton per mm square. Length of steel rod is 140 plus 70. So that is the length of steel rod, 140 plus 70, that is 210 mm. And for copper rod it is only 140 mm. So this is a given data. Now let us calculate the stresses induced. So we know the deformations in steel and copper are equal. Assuming that load remains horizontal, each bar will compress equally. So the deformation produced in copper and steel are going to be same. So each rod will undergo the same amount of reduction in length. So that is delta LS is equal to delta LC. Now delta LS is strain into length. Strain is sigma S by ES. Strain induced in steel is sigma S by ES, and strain into length of that particular material will give the change in length in that material. So sigma S by ES strain multiplied by LS will give the deformation in steel. Similarly, sigma C by EC is strain in copper into length will give the deformation in copper. In this case, LS is not equal to LC. Length of steel and length of copper are different, so you cannot cancel it out. So you cannot equate the strains. They are undergoing equal deformations, but these equal deformations are in different lengths. So LS and LC are not getting cancelled out. Hence we can write sigma S is equal to ES by EC into LC by LS into sigma C. ES by EC into LC by LS into sigma C. Now ES we know it is 200 GPa is Young's modulus of steel, 200 into 10 raised to 3. EC is 100 into 10 raised to 3. LC is length of copper, it is 140 mm, and LS length of steel is 210 mm. So 140 by 210 into sigma C. After reduction, you will get sigma S as 1.333 sigma C. So we get the relationship between stress induced in steel and copper. stress induced in steel is always greater than stress induced in copper, and it is 1.333 times the stress induced in copper. Now you can find out the load taken by each material. So we know that total load is supported by these three rods, and these two copper rods I am considering as one. So PC is a load taken by both the copper rods together. PS is the load taken by steel rod. So PS plus PC is supporting the total load 400 kilonewton. Now PS you can write it as sigma SAS, and PC is sigma CAC is equal to the total load P. AS we know, it's already given, AS is 1000 mm square, and AC is since both the rods are taken together, 1200 plus 1200, 2400 is the area of copper, and that is equal to 400 kilonewton, or 400 into 10 raised to 3 Newton. Now you can substitute for sigma S from the previous relation which you got. Sigma S is 1.333 sigma C. After substituting that, when you reduce, you will get sigma CS 107.15 Newton per mm square. So you get the stress induced in copper as 107.15 Newton per mm square. Now after getting the stress induced in copper, you can find out the stress induced in steel as 1.333 times of this value, so which will work out to 142.83 Newton per mm square. So we got the stresses in both the materials. Now you can find out the load taken by steel. So load taken by steel, you can use the equation sigma S AS. Stress into area, corresponding area will give the load taken by that material. So stress induced in steel is 142.83. The area of steel is 1000 mm square, so which will give 142.83 into 10 raised to 3 Newton, or it is 142.83 kilonewton. So steel is taking out of 400 kilonewton, steel is sharing a load of 142.83 kilonewton. Now to find out the load taken by copper rods, you can either use sigma CAC or subtract the load taken by steel from the total load P. So you can also use PC is equal to P minus PS, total load minus load taken by steel. Total load is 400 kilonewton minus the load taken by steel is 142.83. So that works out to 257.17 kilonewton. So you got the load supported by both steel and copper. So that's all for today. Thank you for watching.